They lurk in the shadows of our solar system, massive rocks traveling silently alongside Venus. Invisible to our telescopes, these asteroids could one day unleash devastation upon Earth. This isn't science fiction. It's a real threat emerging from recent astronomical studies, and it's closer than we think. A groundbreaking study has revealed a swarm of city-killer asteroids co-orbiting with Venus. These celestial bodies, hidden from our view, possess the potential to collide with Earth, causing catastrophic damage on a regional or even continental scale. Their invisibility and the sheer unpredictability of their trajectories means we might never see them coming until it's too late. This discovery has exposed a blind spot in our planetary defense network, one that could cost lives if left unaddressed. And for now, we are staring into that blind spot with limited tools and growing urgency. In May 2025, researchers led by Dr. Valerio Caruba of São Paulo State University in Brazil published a detailed investigation in astronomy and astrophysics. Their study, titled The Invisible Threat, assessing the collisional hazard posed by the undiscovered Venus co-orbital asteroids, was the result of a collaboration involving institutions in Brazil, France, and Italy. Using advanced orbital dynamic simulations, they explored how Venus's co-orbital region, an area long overlooked due to its proximity to the Sun, might be home to dozens or even hundreds of undetected asteroids. While only 20 such objects have been catalogued so far, Dr. Caruba's team believes many more are waiting to be discovered. These asteroids are thought to occupy dynamically complex spaces known as 1.1 mean motion resonances with Venus, meaning they orbit the Sun in lockstep with the planet. However, these resonances are not perfectly stable and can evolve over time due to interactions with other planetary bodies. Venus's orbit, located closer to the Sun than Earth's, places these asteroids in a region where solar glare blinds most ground-based telescopes. Even cutting-edge infrared surveys and space telescopes like NEOWISE struggle to peer into the heart of the inner solar system. These so-called twilight zones around Venus represent a major observational gap. As Dr. Caruba puts it, we are potentially surrounded by objects we cannot see and do not monitor. That is a threat we must address with urgency. What's more, these regions aren't just hard to scan. They're dynamic environments, flooded with gravitational interference from both Venus and the Sun. The asteroids residing there could have existed for millions of years, tucked into temporary zones of orbital balance that are slowly eroding. As observational technology improves, scientists expect to uncover more of these wandering threats in a variety of surprising orbital patterns. The simulations carried out by Caruba and his team revealed something deeply unsettling. These co-orbital asteroids do not behave like those in the main asteroid belt. Their orbits are dynamic, erratic, and inherently unstable over long periods. With Lyapunov times, essentially a measure of how long an orbit remains predictable, averaging just 150 years, their paths could change drastically over short astronomical timeframes due to gravitational nudges from nearby planets, especially Earth and Mercury. Some of the asteroids studied, including 2020 SB 524522 and 2020 CL1, range in size from roughly 330 feet to well over 1,300 feet in diameter. For perspective, an impactor of even the smaller size could release energy equivalent to multiple nuclear bombs, flattening a city or disrupting regional infrastructure for decades. Larger objects would produce continent-scale devastation and global climate effects. One simulation showed that over a few thousand years, several of these asteroids could be nudged out of their stable Venusian paths, drawn by subtle gravitational resonances into Earth-crossing orbits. One particularly chilling aspect of the study is how these asteroids can be perturbed without any immediate warning. As their orbits evolve, they may appear stable for centuries before suddenly transitioning into chaotic paths due to cascading gravitational effects. This unpredictability makes long-term tracking and risk assessment extremely difficult. These changes don't require a massive impact or an obvious event. Sometimes, the mere gravitational influence of another passing object is enough to cause orbital drift. It's like balancing a marble on a plate. One small vibration and it rolls off unpredictably. More alarmingly, these objects don't follow consistent orbital planes. Some have inclined paths, meaning they could approach Earth not just from the ecliptic plane where most asteroids reside, but from above or below, reducing warning time and complicating deflection missions. These orbital peculiarities make them elusive not only to observation, but also to long-term impact forecasting models. Their very nature defies easy prediction, and that unpredictability is a danger all its own. The study is a sobering reminder of how much we still don't know about our immediate cosmic neighborhood. While billions have been invested in tracking near-Earth objects, NEOs, our gaze has primarily focused outward, toward the main asteroid belt, distant comets, and Trojan clusters. The inner solar system remains a dark spot in our defense plans, figuratively and literally. The researchers strongly advocate for dedicated space-based telescopes operating near Venus's orbit, perhaps piggybacking on future planetary missions to scan this uncharted region. One potential solution is to deploy telescopes at Lagrange points near Venus, where they could observe the inner solar system in infrared and ultraviolet light. These instruments could monitor previously hidden regions and alert Earth to any inbound threats with decades of warning. Such missions would not only help us understand Venus's local environment, but might also reveal unknown patterns in asteroid formation and migration within the solar system. The consequences of delay could be irreversible. As Dr. Karuba and colleagues warn, the threat is real, even if invisible. The earlier we detect, the better we can protect. Their call to action also includes increasing international cooperation through bodies like the United Nations Office for Outer Space Affairs and NASA's Planetary Defense Coordination Office. In an era of growing space awareness, defending Earth from celestial impacts is no longer the stuff of sci-fi blockbusters. It's a global imperative, and it starts with shining light into the darkest corners of our solar system. Their message is clear: ignorance is not safety. The more we learn about these hard-to-see asteroids, the more we realize how fragile our assumptions about space safety have been. It's time to shift our gaze inward, not just to better understand Venus, but to better protect ourselves. In the silent corridors of space, danger doesn't always come from where we expect. The swarm of hidden asteroids near Venus may never strike us, or they could become the next planetary emergency. Our future may depend on how quickly we can illuminate this blind spot. If we fail to act, we may find ourselves blindsided by a threat we never saw coming. So stay curious, stay alert, and stay informed. Subscribe now for more real, recent science, from dark skies to deep oceans, that just might change the way we see our world and how we defend it.